All right, take a look at both these triangles. With what we've talked about so far with the law of sines, it will not help us in this situation. With the law of sines, we need to be able to compare a side with its angle and set up a ratio. And we would have too many variables in that proportion. 6 is to sine of A, as 8 is to sine of C. That's no good. Over here, we would have the same problem. 7 is to sine of A. Side C is to sine of 78. We don't have the ability to make a proportion with just one variable. And so what we need here is we need the law of cosines. Law of cosines right here, you can zoom in. I just zoomed in, didn't it? Right here we have basically the same pattern. It just depends on what pieces we have, what angle we have, or what angle we're looking for. Thank you, Java Update. It depends on what pieces we have, what angle we're looking for, but notice the pattern. A squared equals B squared plus C squared minus 2BC cosine of A. When it starts with A squared, it ends in cosine of A. All the other letters are B and C. B squared equals A squared plus C squared minus 2AC cosine of B. Notice when it starts with B, it ends with B. And the other letters are both A and C. C squared is A squared plus B squared minus 2AB cosine of C. Notice when it starts with C, it ends with C. All the other letters are A and B. It is a long formula, but it is quite simple to remember because of that consistency. Let's take a look at this situation. A hockey player attempts a shot. He is 20 feet from the left goal post and 24 feet from the right goal post. If a regulation hockey goal is 6 feet wide, what is the player's shot angle to the nearest degree? We want to find that angle right there. Look, they label it for us. They say this is the shot angle. We want to find that. So I want to find that angle A. Well, I can use my law of cosines to find the angle A. So I'm going to start with A squared equals B squared plus C squared minus 2AB cosine of A. Since it started with A, it ends with A. I am looking for that angle A. Plug in my A value, which is 6. My B value, which is 24. C value is 20. 2 times 24 times 20 cosine of A. Let's start typing some stuff in. We know what this is. This is 36. I'm going to go ahead and 24 squared plus 20 squared gives me 976. 2 times 24 times 20 is 960. Cosine of A. I need to subtract 976 from both sides. 36 minus 976 gives me a negative 940. Before I can get A, before I can do the inverse cosine, I need to divide both sides by that negative 960. And I get a fraction here. That's 47 48ths. That'll be easier than writing down that decimal. Inverse cosine both sides. We know that's where we're going here. And I get 11.71. This is to the nearest degree, so that would be 11.71. Comes out to be 12-ish degrees. And when we look back at this triangle, we're like, okay, that side over there across from A is way shorter than the other ones, so 12 degrees does not sound that crazy. All right, finishing up here with the law of cosines. Here we have the side angle side situation. So we're going to need to use the law of cosines to first find that missing side length C. So to do that, I'm going to set up my law of sines to find C. It's simple as C squared equals a squared plus b squared minus 2ac cosine, minus 2 times a times b times cosine of 65. Remember, when we're doing the law of cosines, if it's c squared over here, then it would be a squared, b squared, ab, and then the angle c filled in at the end. Notice how all of these are just values, so we can type this into a calculator exactly as it looks. 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of 65. Thank you, Java update. And c squared is about 55.19-ish, but I wouldn't even really round that because I'm just going to take the square root of the answer right there in my calculator, and this comes out to be about 7.4. It says round lengths to the nearest tenth, so it's about 7.4. Now, it'll be tempting to use the law of sines now to find one of our angles, but I'm going to highly, highly recommend use the law of cosines. In fact, I don't recommend it. I say this is what you should do. You should use the law of cosines, because if we go for the law of sines now, the problem is we're basically still dealing with an angle side-side situation, a side-side angle situation. That's kind of still what we're dealing with, because we still only have one angle and then a bunch of sides. So if we can find two angles, that is really where the money's at in order to use the law of sines. So I'm going to use the law of cosines here to find angle B. You could find angle A first, I don't care, but I'm going to find angle B. So 8 squared equals 5 squared plus 7.4 squared minus 2 times 5 times 7.4 times cosine of B. You've seen the law of sines work out like, or law of cosines work out like this before. 64 equals 80.19-ish. 2 times 5 times, well, that's just going to be 74. Cosine of B, subtract that over. Divide both sides by negative 74. And take the cosine of that value, or the inverse cosine of that value. I take the inverse cosine of that value. I get about 77, roughly 77 degrees for B. At that point, we can subtract these from 180, which gives us 38 degrees. Like I said, law of sines will sometimes work, but remember, you're working with the angle side-side, a side-side angle situation, which we always have to be very careful with. And to limit that, just use the law of cosines twice. It's going to make it easier on everybody.